Hi everyone, welcome to this webinar on the Visual Data Prep tool in Unreal. In this presentation, we're going to optimize AEC and manufacturing CAD assets using the Visual Data Prep tool. Now this tool is a high-level tool for data prep for non-programmers. The visual UI in it allows the user to create a chain of actions by stacking up blocks of selection filters and operators, and it's very easy to use. So here's a quick high-level look at how the Visual Data Prep tool works for us. We're going to be using Revit, Rhino, and Maya today. Now, in the case of Maya, we're not actually going to be installing a Datasmith plugin, but we're going to be using a format called GLTF. And we'll talk about that more when we get to the section where we're using Maya. And then from there, we're going to import the Datasmith files into Unreal, but rather than use the normal way of importing those files by simply importing from the Datasmith button, we're going to use the Visual Data Prep tool. Now here are some of the things that the Visual Data Prep tool can do for us. Users can do things like creating LODs, setting up lightmap UVs, substituting materials using material data tables, deleting and merging objects, and this will help to optimize your draw call count. And it can do these things based on selection factors like object class, object name, metadata tags, layers, tagging, and a lot more. And the other cool thing about it is that users can create custom functionality. So you can create custom selection filters as well as custom operations using Unreal's built-in blueprint system. So here are some of the things I hope that you will all walk away from this webinar with today. So we're going to start out with a basic high-level intro to the UI and workflow, and we're going to do that using a Revit asset. So it's going to be an AEC architectural asset. And then we're going to also take a look at some other techniques using the Data Prep tool, including substituting materials using data tables, as well as optimizing your performance by merging meshes and creating LODs. We'll also look at creating your own custom blueprint operators. So if you want to do something that isn't built into the tool, you can create your own. We'll also look at adding some pre-built blueprints into the import process. So for vehicles, you could add headlights, or for like a helicopter, which we'll look at as our last project today, you could have a spinning rotor blade. You can have a door that opens in an architectural scene, and so forth. And we're also going to look at how to use the Data Prep tool to create customizable, repeatable recipes. And this will allow you to recreate your assets, re-import them with different settings. So you can have different materials and so forth. All right, so to get started, we need to do a few things first. First of all, we're going to need to get a couple of plugins installed. You're going to need plugins for Datasmith as well as the Data Prep tool. Now, Datasmith and Data Prep plugins, we're going to need those for Unreal Engine, but we're also going to need to set up some plugins for our tools. And today we're going to be working with Revit, Rhino 3D, as well as Maya. To install the Datasmith Exporter plugin for your specific DCC tool, there are a couple of ways you can get it. We can, first of all, download it using the Epic Games Launcher, then click on the Marketplace, and from here we'll search for Datasmith. And we want Datasmith Export Plugins, and this is going to take you to the website. From here we can scroll down and we'll find all the plugins that are currently available. We have 3ds Max, SketchUp Pro, Revit, Navisworks, Rhino, and Graphisoft's ArchiCAD. For today's webinar, I'm going to be working with Revit, so I download the latest version here, and then Rhino, and I would get that from here. Now, in order to use Datasmith and the Data Prep tool, we're going to need to enable them in the plugins. We'll start out with Datasmith, so we'll simply search here for Datasmith, and we're going to enable the GLTF importer here. We're going to be importing from Maya using that. We're also going to need to enable the main Datasmith importer, and we'll go ahead and enable the CAD importer as well. All right, and next we need to enable the Data Prep plugins. So here is the Data Prep Editor plugin. This is the main plugin here. We'll want to enable that. And then there are some additional operations that you can get for modifying geometry, such as remeshing geometry. For that, we'll need to enable this second plugin here. So to get our feet wet, we're going to do our first project here using a Revit asset. We're going to bring in this building here, this ArcViz project, into Unreal using the Visual Data Prep tool. Let's get started. Okay, so our first example I have loaded up here inside of Autodesk Revit, and it's basically an ArcViz scene that we're going to be bringing into Unreal and using the Visual Data Prep tool to make some adjustments to it on import, such as modifying materials, replacing assets, and things like that. So obviously we installed our plugins, and you'll find the Datasmith plugin at the top here on this tab. And this will allow us to make a direct connection. This plugin will allow us to make a direct connection into Unreal, but we're not going to be using that. Instead, we're going to be using this Export 3D View option here. But before we do, let's look at some things here that will help us when selecting the different assets or elements inside of Revit when we're inside of the Data Prep tool. So first of all, the Data Prep tool, if you recall, we can select things by all sorts of different means. We can select elements by layer name, by element name, as well as metadata tags, and several other options. So let's select the wall over here, and looking on the Properties panel, we can see we have a lot of metadata here that is already filled in for us. We have things like the area of the object and so forth. And then also, if we go to Edit Type, we've got a bunch of metadata in here, such as family type parameters down here that we can use, and we can select based on any of this information. Also, we can select using tags. And inside of Revit, if we go to the Manage tab and then click on the ID of the selection here, we'll get the ID of this particular element, and we can actually select by this using tags inside of Unreal, because this information will be added as a tag when we import. So with all that information in hand, we're ready to export the scene. We'll simply click on the Datasmith tab and export the 3D view. Okay, so with our plugins installed, we're ready to begin working here. We're going to first need to create the Data Prep asset. The reason is we're not going to be using the normal Datasmith import process. Instead, we're going to be importing through the Data Prep tool. To do that, we need to right-click, and then we should find the Data Prep category here, assuming our plugins are fully installed, and then Data Prep asset. And now we can rename this to Data Prep ArcViz. So this is the Data Prep window. We have our usual toolbar along the top, along with some buttons that you may not be familiar with, and we'll explain those in a moment. Here below this, we have our content browser for the Data Prep workflow. So using Data Prep, we're going to be creating a temporary space, kind of a sandbox, where all of the assets we import will be stored as we're working on them. They won't be added to the project until we actually commit them to the project. Next to this, of course, we have our 3D viewport. To the right of that, we have our outliner, which will obviously list all of the objects in the scene when we import. Next to that, we have our inputs rollout and our output rollout, as well as a parameterization rollout. We'll explain what that is a little bit later. Now, before we go any further, let's go ahead and import the Revit scene into the Data Prep workflow. For that, we need to click this Add New Producer button here, and we'll choose Datasmith File Importer. And then, of course, we'll locate the exported Datasmith file from Revit. Now, under Output, we need to specify where we want to store this in our content browser, as well as the name of the level that the content will be saved to. The way the Data Prep tool works is that it's going to export the final asset into its own custom level, which you can then stream into any other level. Now that we've selected our Datasmith project, we need to go ahead and begin the import process by hitting the Import button. Okay, so now you can see these three areas have been populated. On the left here, this is what our content browser is going to look like when we commit everything to the project. In the middle, of course, we have our 3D scene. It brought in the cameras, the trees, the geometry, and if there were any lights in here, we could have brought lights in as well. And then, of course, on the right, we have our world outliner. This is showing the current state of the imported assets. You can see also that the Execute and Commit buttons are no longer grayed out. The Execute button will be used when we're ready to begin running the different operations that we're going to be adding. And then the Commit button is the final button we press. Once we're happy with everything, this will commit all of the changes to the actual project. So looking below, the next tab we have here, this is where we're going to find our selection filters as well as our operators. At the top, we have the selection filters. And you can see we have a lot of options here. We can filter by class, so we could specify this object is a class of whatever. We can also filter by bounding volume for large and small objects, triangle count, vertex count. Actor label is going to be what you see here in the world outliner. Then metadata value, as well as object name, actor layer, and actor tag. Now, after this, we have all of our different operations. I'm not going to list them all off. Obviously, there's quite a few. We will be working with some of them, though, so you'll see some of them in action. But you can see here we have things like adding tags to an asset, merging assets. We can set the metadata on an asset. We can flip faces. We can create LODs. We can create substitute materials, all sorts of stuff here. So let's go ahead and look at the workflow here. We're going to do just a few basic steps so you can get an idea of how easy it is to work with the tool. Now, a very common workflow here is going to be to substitute your materials. So for instance, I want to go ahead and substitute all of these wall materials with something inside of Unreal with one of the Unreal PBR shaders. So to do that, we first need to select some objects. Now, I could go in here and select each individual object by name and just keep repeating the process, but this is where the selection filters come in handy. So what we're going to do is we're going to select by metadata first. So we'll go over here and select the metadata value node, and we'll drag that into the viewport. The viewport will allow us, much like a graph editor inside of Blueprint or the material editor, to drop nodes in, and those nodes will basically be connected from left to right. When you add a new node to the graph, you can rename it here, so you can see it says new action by pressing F2. So for this first action, we're going to just call this replace wall material. Now, we can see within our replace wall material, we have the node that we dragged in, filter by metadata. Now, the key that we're going to be filtering for is called element family. And this is the metadata key taken from Revit. From here, we're going to specify wall. So what this is meaning is that anything that contains the word wall in its element family metadata will be selected. So not only one object, but any object with this metadata. Now, if you want to see the metadata in Unreal, it's actually quite easy. So I have a wall selected here right now. And on the Details panel, I can scroll down to the very bottom where you'll find Asset User Data. Opening this up will allow us to drill down until we find the Datasmith user data. And then we can open that up further. And then we're going to find all of the different metadata tags here. So for instance, we're looking for element family. So if we scroll down, and there we go, element family. And this is basic wall. This means that this object will be selected, as well as any other object that has the word wall in it. So from here, we're going to substitute the material used by any of these objects that we have selected. Now, I can scroll down here, and you should find substitute material under on object, or you can simply search for the word material. And we'll drag substitute material into our replace wall material block. So this will allow us to search for a material with the name that we specify and then replace it with the one we want to replace it with. Let's go ahead and specify that one now using the drop down. I'm going to search for concrete. All right, and then we're going to change the material search here to concrete and then star. Star can be used as a wildcard. All right, and this is our first block added into our workflow. And if we want to execute this now to see what it looks like, we'll simply hit the execute button. All right, so now you can see that any of the objects in the scene that had the element family wall meta tag or metadata have had their materials replaced. Now, another thing we can do inside of the tool is to add collision. So collision comes in handy, obviously, if you're going to have the scene be interactive where a user can walk around inside of it. You don't want them to be able to walk through walls and so forth. So what we can do is we can add collision using, again, the metadata tag for the walls. So what we're going to do, and rather than create a new block, we're going to simply add a node here inside of our replace wall material, and we're going to search for collision, and we're going to use simple collision. So we'll just drag that in, and we'll place it underneath the other node here, the substitute material node. We could even place it in the middle here. You can see as I mouse around, I can place it in different spots. Just keep in mind that all of these nodes down here are operating on whatever this filter is set to. Let's go ahead and execute this again, but keep in mind we don't have to execute every time we make a change. We could just keep building up our recipe here. All right, so the Data Prep tool has finished executing our instructions. If we go to our View Mode button here, we can change this to Player Collision, and we should see all of our collision detection in there. Another way to select objects, again, is by tags. So let's go ahead and drag a new selection filter here. We're going to be selecting actor tags. We'll drag that over to the right this time, and you can see that the circle lights up yellow, letting you know you're on a new step. So we're going to be filtering by a specific tag that came over from Revit, and that's the tag that is currently set on the floor. So if we select the floor, And then on the details panel, we can go up to the tags section. We should find the tags that were added there from Revit. And the tag we're going to use is the ID of that object. So I'm just going to right click and copy that and then paste that into our filter by tag. So this is letting us know that we only want to select the object with this ID. And now we're going to again substitute the material, but rather than dragging it over from our box over here, we can actually copy and paste by simply holding down Control and then dragging it to a new step. This time we're going to change back to an asterisk for our wildcard, and then we'll change our material dropdown to MI_decking. All right, so that's just another way of selecting objects. But you can see here we're basically only adding one material at a time. There's a much better way, and that is to use a material lookup table. But before we can use the material lookup table, we need to create one. So let's do that. To create a material lookup table in the content browser, we'll need to go to Miscellaneous and choose Data Table. From here, in the dropdown, we'll select Material Substitution Data Table, and then we'll call this M_lookup table. Now, the way the material lookup table works is that we can add rows into the table, and using these rows, we can take the material name from the old material imported from Revit, specify that name down here. So for instance, I'm going to specify the metal material because I know we had some materials come in from Revit with the name metal. We can use the drop down to determine if it just contains the word metal or it's an exact match, and then specify the Unreal material that will replace it using this replacement drop down. So the material I'm going to use is called Metal Nanowell Clear Anodized 1. And then I would select the next row and then do the same thing here. We're going to replace the glass material. And then the third one here, we're going to be replacing the wood floor material. All right, so there are 3 examples. We can add many more rows here, obviously, but for now, let's go ahead and save this. And then back in our data prep window, we can now replace the materials using that lookup table. So again, we're going to search for material, and the one we want is substitute material by table, and we'll drag that into our third step. So you notice I didn't use a filter here, and that's because we don't need to. Whenever you want all of the objects in the scene to be affected by a node, you don't have to use a filter selection. So this means that everything from the root node all the way down will have this node applied to it. All right, so all we need to do now is specify our lookup table. Let's go ahead and execute this and see the result. All right, so now that we've executed the operations, we can see that all these materials have been replaced. The glass material as well as the metal material here around the glass and the wood floor. All that was replaced using our lookup table. So you can see the power of using a lookup table. Obviously, you can replace a lot of materials in one go, and you don't have to go through and do each one manually like this. Now you may notice that in our Revit scene here, we have some fairly ugly trees. And there's a couple of things that we can do with these inside the data prep tool. We can delete them or we can even replace them. So we're going to use a different selection method this time. And now we're going to use object name for our selection. So I'm going to drag that into the graph here. And we're going to set this to contains the word plant. In fact, if we click on one of these trees and then we'll search for that here, we can see that it has the word plant in it. So we don't need an exact match, but we definitely want the contains drop down specified. Okay, so once we get a selection of all the different plants, we can easily delete them by simply dragging a delete object node into our new action here. And then we can execute to see the result. All right, so all of the plants have been removed from the scene. All right, let's go ahead and commit this to our scene now. Okay, so after committing, we can see that the scene has been imported into our map file here. We've got the trees removed that we didn't like. All the materials have been replaced. And if we go over to the Levels tab here, we can see the Data Prep ArcViz map. And if we were to hide that, that will hide our import. So if we look below in the content browser, you'll see the Data Prep ArcViz map there. That's being loaded in using level streaming. And next to that is the actual Data Prep ArcViz scene. Keep in mind, however, if you were to drag that into the viewport, it will drag the scene in, but it won't have any of the data prep changes to it that we've made using the tool. That should give you a good understanding of the basic workflow here inside of the Visual Data Prep tool. Unfortunately, we don't have enough time today to go into much more detail here, but you could certainly go to town. You can merge the assets together to reduce draw calls. You can add custom blueprints that have animated effects, such as doors that will open when you walk close to them, and all sorts of things. And some of these things we will be looking at in some of the next projects that we're going to discuss. And that brings us to the next project, which is going to be a manufacturing example using Rhino 3D. So let's go ahead and take a look at that now. Here inside of Rhino 3D, we have the buggy we're going to be exporting to Unreal. You may notice that right off the bat, we've got some flipped faces here, some flipped normals on the tires. We could fix this here inside of Rhino, but we're going to be doing that instead in the Visual Data Prep tool. We can see the buggy is made up of multiple layers here, and we can, of course, use these layer names as they will be imported as actors, so we can filter by those. Also, the layers themselves, as well as some of these objects in the scene, have materials applied to them. And these material names are important because inside of the data prep tool, we're going to be using a material lookup table again so that we can capture these material names and replace them with Unreal materials. Another option to us is metadata. So if we go to the properties page and select the car body and then go to the attribute user text section here, we can see I've added some metadata. So in this case, it's type body. If we select the glass here, we'll see the type is glass. Likewise, we've got the frame object here as type frame. And so we're going to be using all of the metadata. All of these objects have metadata on them. And I'm going to be using that metadata to optimize the model because right now it's actually pretty high on the mesh count. It's running around 600 meshes. So we're going to be merging all those meshes together using the metadata. And I'll show you how that's done inside the tool when we get there. One of the great things about Datasmith exporting from Rhino 3D is that it will export all types of geometry. So for instance, the tires here, if we go ahead and explode this, you can see that these are just patches basically. These are NURBS objects. Well, that's all we really need to look at here inside of Rhino. We've got the Datasmith plugin installed, so we'll go ahead and select all of the mesh objects in the scene and go to File, Export Selected. And we want to make sure that we have the Unreal Datasmith file format selected, and then we'll do an export, and we'll see you in Unreal. Here inside of Unreal, we're ready to import using the Visual Data Prep tool. So we're going to go into our content browser, and we'll create a new data prep asset. As before, the first thing we'll need to do is add our producer. So we'll click on the input button here, and then browse to our Datasmith file. After this, we need to begin the import process. Okay, so the buggy's been imported and we're ready to begin working on it here. But before we do, let's jump back into the editor real quick and let's have a quick look at the actual Datasmith file. So I've already imported it and I'm just going to drag it into the scene here. So you can see that clearly this doesn't look very good. The tires, obviously, they need to be flipped. They're normals. The materials, they look terrible, so we're going to have to replace all of those materials. And this is actually way too small. So the first thing we're going to do is we're going to scale it up. Now, if you look over here in all the operations, you're not going to find any scale operations. So we're going to need to create a custom blueprint to do that. So back in the content browser, we're going to create a new blueprint class, and we want to make sure that we're looking at all classes at the bottom. And then we'll go down to the data prep classes. We'll open that up. We have a couple of options. We can create a fetcher, and that's for filtering your selection. But what we want to do is perform an operation. We want to scale the actor. So we'll go ahead and use data prep operation. We'll call this BP scale actor. All right, so we have our scale actor blueprint up. We've got our event on execution, which begins at the beginning of the operation when this operation gets run. And then we're grabbing the context of our data prep. So that's all of the actors that will be selected. And the first thing we want to do is we want to loop through those actors. So we'll pull off of our output here, our execution flow, and we'll search for a loop for each. There we go. And we're going to plug the array of objects that are selected into the array input. So what we want to do now is set the actor's scale. But to do that, we're going to need to get an element from the array. So we're going to be getting them one at a time since this is a loop. And we want to cast this as an actor. So we'll do cast to actor. Now that we know it's an actor, we can pull off of the as actor output and do a set actor scale. Of course, we want to make sure we come out of our loop and go into the cast to actor. And then we need to specify the scale amount. And for this, we're going to use a variable. So we'll add a new variable and make sure that it is public. And this way, we'll be able to see it in the data prep tool. And let's call this variable scale factor. And we're going to change the type to a floating point value. Now we can drag that in and then plug that into our Scale 3D input there, and Unreal is smart enough to automatically convert that for us. And that's all we have to do. We can save and compile. Now if we jump back over into our data prep, we should find it. Scrolling down under user defined, there's our BP scale actor. We can drag that in. So because we haven't selected any filters, this is going to apply to the entire thing. And let's go ahead and set our scale factor to a value of 2. So if we execute this now, we should see our car get a little bigger. There you go. All right, so the next step is going to be replacing the materials on the car, and we're going to use our lookup table. Under on object, we're going to substitute material by table, and then we'll choose our table. And we can execute that to see the result. All right, so there we go. We've got all the materials replaced, and it's been scaled up. Looks good. We still have some normals that need to be flipped, and I'd like to add some headlights and taillights to this. We'll go ahead and create a new blueprint class. In this case, we're going to make an actor and call it BP underscore headlights. Now, all we really need to do in our headlight actor here is spawn a light or two. So I'm going to go ahead and choose add component, and we'll search for light. We're going to drop in a rectangle light, and then we're going to add another one here. We're going to add a spotlight so we can get a nice effect. Now I'm also going to make a few tweaks here. We're going to change the intensity value as well as adjusting the source width and radius. And we might as well add a light profile to this. So if we go down to light profiles, I'm going to use one of the built-in profiles, complex IES on this light. All right, for now, that's really all there is to it. We'll go ahead and save and compile that, and we're ready to use this inside of our car. Now, if we look for the lights here, we can scroll down. We'll find them under lights. And for the headlights, they're under front. What I want to do is spawn my headlights right in front of that. So we're going to use that by doing a selection here. We're going to filter by actor label, and then that's going to be the word front. Now I want to make sure we spawn a headlight on both of these front panels here. So we need to get the children of front. So we'll use a select hierarchy, and we're going to do immediate children. And we don't need to include the input, the front actor. And then we just need to go ahead and spawn our actor in. So we'll scroll up here to spawn actors, drop it in, and then select our new headlight from the dropdown. So just like with the headlights, we need to find the tires, and we can see that all the tires here are actually under the actor tire. So we'll go ahead and copy this over, filter by actor label again, and in this case we want tire. And we're going to select the hierarchy again. We want the immediate children. And again, we don't want to include the input. And now we can flip the faces, which you'll find under on mesh. Drop that in. Another thing we can do inside of the tool is generate UVs, so we can actually do some unwrapping. So on the sandboard here, you can see that clearly the texture mapping on this is not exactly lining up. So what I want to do is create some new UVs that will make use of this material properly. So of course we'll need to select the sandboard, so we'll use a filter by actor label. So I'm going to select the sandboard in the outliner here, and I'm going to right click and copy the label and paste that into my input. Now we'll search for generate and grab that generate unwrapped UVs node there, drop it in, and we're going to set this to specific channel, and channel 0 is the one we want because that's our channel for all diffuse textures. And we're going to set the angle threshold to about 60, and that should do us. So now when we execute this, this is going to generate new UVs for channel 0, and those new UVs will correspond with the texture map that I've created. Okay, so there's two more things I want to do inside of my visual data prep here, and that is going to be optimization related. First of all, if we look in the viewport here, we can see the number of static meshes is 670. And that means there will be at least 670 draw calls at runtime per frame, possibly more, because the amount of draw calls that it takes to render something is the number of meshes times the number of materials that each mesh has. So we want to bring this down significantly. And second of all, we're going to create LODs so that the mesh gets less complicated or less detailed as it gets further away from the screen. And this will help to optimize performance as well. So as far as merging our meshes together, we're going to use a two-step process, and this is where the metadata tags will come in handy. I want to merge everything that is related to the body into a single mesh, everything that is related to the frame in a single mesh. The wheels will each be their own mesh, and then all of the equipment will also be merged, leaving us with about 6 to 8 meshes total. Let's start with the body. We're going to use the selection filter that lets us select by metadata. So we're going to grab that, drag it in, and we'll set this to exact match as well. And in this case, we're looking for the metadata tag body. If you remember, this is one of the metadata tags we had set inside of Rhino. The key name was type. Now, what we're going to do here, instead of merging all of these together, we're going to actually tag it. We're going to add a tag. So if we search for add, we should see add tags, and we can drag that in. And what we want to do is add a new tag to all of these assets that are tagged with metadata body, and we're going to give it the tag car body. And so what we're going to do is we're going to merge everything together into a single piece using this tag. We'll go ahead and do another metadata search. So we'll filter by metadata value here. And in this case, we're looking for the metadata value of frame. Again, the key is type. And then we'll add a tag again to this. So we'll just copy that over, and it's going to be car body again. So let's just copy this whole thing now. And then for this one, we're going to change our metadata to suspension. Now from here, we can now merge all three of these together using that tag. So we'll filter by actor tag. The tag is car body, and then we're going to merge. The new static mesh we're going to create, we'll call that SM_car body, and we'll set the pivot point to 0. So of course we need to go through here and continue to merge objects together, get our static mesh count down as low as possible, and then the next step would be to add LODs. So let's do that now. So LODs, or level of detail, are pretty easy to do here inside of the tool. All we need to do again is get a selection. In this case, we're going to select by actor label, and we're going to look for toBlar_edited. We'll of course need to grab the hierarchy of children below it, so we'll get select hierarchy, and we're going to go with all descendants this time, not just immediate children. And now we're ready for our LOD node, so we're going to grab set LOD under on mesh, drag that in, and then we can add our LODs in from here. We're going to use 4 LODs, so go ahead and hit the plus button here 4 times to add 4 of them. And now we need to specify the number of triangles we want the mesh reduced by, as well as the screen size, how big the mesh is on the screen before it will go down to the next LOD. So for this first one, we're going to leave it at a value of 1 for percent triangles. That means 100%. And we're going to change the screen size to 0.75 or 75%. The second one, we're going to do that one at 0.75 and then the screen size at 0.5. Then we'll go down to 0.5 or 50%. And the screen size in this case, we'll set that to 0.25. And then the last one, we're going to set that one to 0.1. And then the screen size, we're going to set that also to 0.1. All right, and that's all we really have to do here. We'll need to, of course, execute one more time. All right, so the execute is completed. Let's go ahead and have a look at those levels of detail. We'll go to our View Mode button, choose Level of Detail Colorization, and then Mesh LOD Colorization. And you can see right off the bat that the meshes are changing color based on the distance. So the closer we are, a mesh, I should say, the closer it is to the screen, it should look gray. But as it gets smaller on the screen, so if we move back here, the body should turn red. So that is the next level down. And then if we move back even further, it's going to go down to green. There we go. So it's even smaller. So this would be the next level down. That'd be about half the number of triangles. And then if we go even further, the last step is going to be blue. And that's going to be about 10% of the triangles in the mesh. So this will help at runtime improve your performance. All right, so that's all we're going to do in here. I've got another version of this that's already fully baked with all the different assets merged together and so forth. And I'm going to go ahead and load that up now rather than rebuild this whole thing from scratch. And then we'll go ahead and commit. All right, so I think we can see once we've committed the project to the scene how nice everything came out. And the materials look great. And the headlights and the taillights that we added, all looking fantastic. Not to mention, this is only 7 meshes. So we've got the body, then we've got the 4 tires, the sandboard, and that's about it. All right, so there's one last trick that we can use with the data prep tool, and that is to create recipes that can be reused to import a similar object, but to make minor tweaks to it, such as material changes and so forth. Now, the way we do this is by creating an instance of our data prep asset. So when we right-click on that, we can create an instance. Now, in order to populate our instance with options, we need to specify those parameters here inside of our data prep master. So first of all, let's say that we'd like to use a different material lookup table for a different version of the car. To do that, we simply right-click on this material data input and click on Link to Parameters. and this will give us the option to specify a new parameter. Now on the top right here, if we look under parameterization, we can see our new material data lookup table input field here. And so now we can go through all of our different blocks here and find other inputs that we'd like to make available in our instance. So for instance, some more examples here that we could make use of. When we're generating LODs, we might want to go ahead and specify a different body file that we're using. So let's go ahead and link that to a parameter. So we'll call this one root actor name. And we might as well also add our scale factor as a parameter. Now in our instance, we can see that we have all these parameters available to us. First of all, we can choose a different input file. So let's go ahead and do that now. We'll use tubular edited 002, and we'll make sure to give it a different map name. Now we need to specify the different parameters we made available. So we'll choose a different lookup table this time for the materials. We need to specify the new root name, so that was tubular edited 002. And let's make this one slightly larger. From here to run the process, all we have to do is right-click on our instance and choose Execute. All right, so now we can see our second version of the car has finished building and committing to the scene. You can see that it doesn't have equipment like the black one does. It doesn't have a sandboard, and it has a different material. So creating instances like this is a great way to create multiple different versions of similar assets that can use the same recipes. This is a huge time savings. Okay, I think they look great. So now that our buggies are fully imported from Rhino, let's go ahead and move on now to bringing an asset in from Maya with the Data Prep tool. In our final project for the day, we're going to look at how to bring this helicopter from Maya into Unreal using Visual Data Prep. And we're going to replace the materials, obviously, but we're also going to set it up so that we can make the rotor blades animate and rotate. But before we can do that, we're going to need a plugin for Maya. We're going to be exporting from Maya using GLTF, or GL transmission format. The plugin we'll need is at babylon.js.com, and from there, if you go to the documentation and then go to Extensions, Exporters, and then look for Maya, you'll be able to find the instructions for installing the Maya plugin. You'll have to go to GitHub under Releases and then locate the Maya plugin zip file for your version of Maya. But once that's installed, we can jump over to Maya and take a look. Before we export the helicopter to Unreal, we need to do a little setup here. And we want the blades to spin inside of Unreal when we import it. So to do that, we're going to need to select the blades here. And there are a couple of things that we could do to allow us to select them in Unreal. We could add metadata here inside of Unreal and select by metadata. We could put all the blade parts on a layer. Instead, I'm just going to go ahead and group them up. So let's go ahead and start by selecting all the parts here. And now let's go ahead and group these. And let's rename the group. And we'll find the Babylon plugin on the top of the menu bar here. Choose File Exporter. And we want to make sure we're set to the output format here of GLTF. We want to make sure Optimize Vertices is unchecked. We don't need to export any animations. And we'll go ahead and export. With the rotor group selected, we can test it by simply rotating it. And we can see there it rotates in Maya very nicely. So it should work pretty well inside of Unreal as well. All right, let's jump over to Unreal now. Okay, so here inside of Unreal, we'll go ahead and create our data prep asset. So as before, the first thing we'll need to do is add an input or a new producer. I'll choose Datasmith File Import. And there is my helicopter GLTF file that we just exported from Maya. Okay, so my folder is already set for me, and the level name will be helicopter data prep map. And now let's go ahead and import that asset. All right, so our helicopter's been imported. Looks like everything has come together pretty nicely. So let's go ahead and begin our data prep recipe. The first thing we need to do is to replace the materials with our Unreal materials. So we'll just do a quick search here for material. And we're going to use a material lookup table, so we'll drop that in. Now I've already created a lookup table ahead of time, so let's go ahead and select it here in the dropdown. First step complete. Okay, so from here we're going to set up our blades so that they rotate, but before we do that, we need to create a blueprint that will have built-in rotation that we can then take the rotor blade meshes here and then insert them into that blueprint. So let's go ahead and do that now. Back in the content browser, I'm going to create a new blueprint class, and this will be an actor, and we'll call this BP underscore rotor blades. All right, so inside of the actual rotor blades blueprint, we need to add a new component. In this case, we need a static mesh component. And this will allow us to insert any static mesh in here that we'd like to use. So for instance, if I go to the drop down here, I could pick this part here and insert it into that static mesh component. But we're going to leave it blank, and we're going to insert the static mesh from the data prep tool. So let's go ahead and clear that out. Now the next thing we need to do is we need to rotate this static mesh. And let's jump over to our event graph for that. So what we'll do is off of event tick, we're going to run a timeline. So let's go ahead and pull off of that and search for timeline. And using a timeline, we'll be able to create different animated effects. Let's go ahead and open the timeline up. And the first thing we need to do is add a channel that we can animate with. So we're going to add a floating point track, and we'll call this track blade rotation. And let's go ahead and set the length to about 10 seconds. And now we need to add our keyframes. So the timeline is a keyframe animated track. So if we shift click here on the left, we'll get our first keyframe, and then on the right, we'll get our second keyframe. We'll select the first one and set the time to 0, and the value we'll leave it 0 as well. And then the second one here, we're going to set the time to 10, and then we'll set the value to 360. So what we want to happen is we want the blades to go around in 360 degrees. So this will allow us to do that. Let's go ahead and zoom in on our animation here. You can see we have a nice linear curve here that will go from 0 to 360. Now one last thing we need to do in here before we close it down is to enable the looping option. This way it will continue to spin the blades. Otherwise it would just spin them one time and then stop. Now we're going to need a reference to the blade static mesh component, so we're going to grab that and then drop it in here. Let's go ahead and actually rename that static mesh component to blades. There we go. And then what we're going to do is we're going to set the relative rotation of those blades. So we'll pull off of blades and search for set relative rotation. There we go. All right, and our timeline will be driving that set relative rotation, and it will use the blade rotation. Now, you can see we can't just plug blade rotation into the rotation input here. We're going to need to make a rotator because that's what this expects. In fact, if you hover over this, you can see it expects a rotator. So we'll go ahead and pull off of blade rotation, search for make rotator, and we're going to plug this into the Z or yaw, not the X. And then from here, we can actually control this rotation by adding a little speed variable that we can adjust. So let's go ahead and add a new variable here, and we'll call it speed. We need to make sure that it's public, and let's go ahead and change the type from Boolean to a floating point value. And then we'll drag speed into our graph. And then what we want to do is multiply this return value by the speed. So let's just go ahead and do a quick multiply. And searching for multiply will give you the scale rotator, so that's what we want. And now we can plug our speed in at the bottom there, and then plug this into our rotation value there. All right, so our blueprint should be all set up. Let's go ahead and just kind of move this over so we can get it nice and organized here. Save and compile, and we're ready to go back to our data prep tool. We're going to need to grab all of the mesh pieces from the rotator blades group that we created inside of Maya, and then we'll merge them together. So let's go ahead and do a selection here, and we'll select by actor label. So we can drag that over here. We're going to do an exact match and search for rotor blades. And that will, of course, get us the top level group actor, but what we want is everything below it, all of the children. So we'll need to scroll down and grab the select hierarchy node, drag that in, and we're going to go with all descendants. And we'll go ahead and include the input, which is the rotor blades actor. From here, now that we have them all selected, we need to merge them. So just scroll up a little bit, and under on actor, we have our merge. We'll drag that in. And then the new actor label, let's call that SM underscore rotor blades. And we'll set the pivot point at 0, so it's nicely centered. Okay, so the second step here will be to spawn in our newly created blueprint and then set that mesh component to our new SM rotor blades. So we're going to need to grab the SM rotor blades. So we'll do another selection operation here by actor label. And then rather than type it, I'll go ahead and just copy it so that we make sure we type it correctly and paste it in there. And then now that we have that new static mesh that we've created that has all the others merged into it, we can go ahead and spawn our blueprint. So we'll scroll down a little here under on actor again, spawn actor at location, and we're going to select our blueprint here. So I'll do a quick search for BP underscore blade rotor, and there we go, rotor blades. And then the final step on this action here is to set the mesh. So if we grab the set mesh operation and drag that in, we'll need to search for SM rotor blades. Now here's a little caveat to this. When you're importing this asset for the first time and running your data prep recipe, SM rotor blades won't exist yet, so you will not find it when you try to search for it. That's because this operation hasn't occurred yet. We actually need to create that mesh and then commit everything so that that mesh is actually spawned or created in our real content browser. Remember, the data prep window is just kind of a temporary location for all of these assets. They don't actually exist yet in our project. So you're going to have to run this twice in order for that to work. Just keep that in mind. Anytime you want to spawn a new mesh that you've created inside of your recipe, you're going to need to run it at least once for these meshes to be created to be usable. Okay, and one last step here. We're going to delete the original rotor blades static mesh now that we have our blueprint-based static mesh. So again, we'll filter by actor label, and that's going to be SM rotor blades, and then we'll simply delete the object. That's going to be under on object here, and that should do it. All right, I'm going to go ahead and execute this now. Okay, now that we've executed, of course, we'll need to commit, but you can see here that in our pipeline we have our SM rotor blades, and if we scroll down here, we should see that we no longer have the original rotors. There we go. So now we can see under the rotor blades group, we no longer have any of those assets. All we have is our newly created rotor blade blueprint, which has the static mesh set. All right, so let's go ahead and commit this. Okay, so we've committed everything to our project. The helicopter looks great. All the materials are properly set up. And if we select the rotors up here, you can see we're selecting the custom blueprint we created. And if we look over in the details panel, our custom variable for speed is there. And let's go ahead and set that to a value of 5, and we'll give it a play test. All right, so we can see our blades are spinning here at a nice slow rate. We've got some nice God rays coming through there as well. Looks great. But remember, we can also increase or decrease the speed. So if we go back to the details panel here, we can go ahead and bump that up, make it even faster, and we'll give it a shot here again. And there we go. So just like that. And if you wanted to, you could easily come in here and create other blueprints that will allow you to increase or decrease the speed during playtime. So for instance, you could have it where the user walks up to the helicopter and then clicks on something and then starts the blades up. Or even gets into the cockpit if you really wanted to go that far. Now, keep in mind, obviously, the helicopter, we didn't do any other optimization in our data prep import process, so we didn't combine any of the meshes here. I think it's about 400 meshes or so. So we'd probably want to go back and do some optimization here on the helicopter as well. Unfortunately, that's all the time we have for the day, so we're going to go ahead and have to leave it at that, but I hope you enjoyed this webinar on Visual Data Prep. As you can see, it's a very powerful tool. Very easy to bring in your assets, whether you're a CAD user or 3ds Max or Maya user. Bring those assets in and visually set it up so that you're bringing your assets in so they're more optimized, so they're using the better materials inside of Unreal for rendering in real time, as well as doing all kinds of cool stuff like adding animated rotor blades or headlights or whatever the case may be. So again, I want to thank everyone for attending. I hope you enjoyed and learned from this webinar, and we'll go ahead and open up the floor now to questions and answers. So thanks again.